Now this thing is open, PyCharm is already open, you see that? So let me make sure that I cover Factorial, which is, Factorial is a recursive function. So on the module for today, we are talking about function that call itself. A Factorial, when you call it inside, the name is Factorial, and you're passing that Factorial of it, you're just doing it. So what is a Factorial? In mathematics, a Factorial, you could just use it by just doing a factorial of 5 and this exclamation mark after it, meaning that 5 factorial is 5 times 4 times 3 times 2 times 1. Every time you reduce one number to it till you reach to 0, and factorial of 0 is 1, factorial of negative is not unknown, and that's why these F statements are there. And then other than that, you go to a range statement, and whatever argument is passed on to the factorial, if I run this one, basically is going to give me factorial of some numbers that I'm going to do the call on it. So the Python code is right here, and then the function factorial is right here, and then I'm calling it here. In order to call it, you just pass on an argument for num. And num here is defined globally, and num here is local. This is the scope of this num is within this function. Once you reach to line 16, then num has no longer have any value within the, it is only defined within the scope of this. This num is global, outside of the function. So this num, when I'm passing it there, I say the factorial of 4 is equal factorial, then it calls this factorial, it comes in, and then it says if num, in this case 4, is less than 0, it's not. So it's equal 0, it's not. Then it comes to this for statement, and then it subtract 1 from it, and num plus 1, because the last number has to be multiplied also. So it increment this one because we're using the word range. Range, remember what you put on the second parameter is not actually the last value that you want to use. So if you want to use the 4, you have to do num plus 1. And that's because of the range. In this case, it's doing that, and then the same thing with factorial of 5. So if I go to factorial of 5, you run it. So this is IDE for PyCharm. If you say that, well, I have downloaded the community version of PyCharm as IDE, can I just compile my code and submit my assignment? Yes, perfectly. That's all I need. I don't need you to go to VI. I don't need you to go to Atom. I don't need you to use Notepad. Just that's an environment that you already have the entire integrated development environment. You do it. And then right here, if you look at it under the setting, that basically it says what Python compiler should use. And then on addition of this information, let's see Python interpreter here. It is going to say that what Python 3.8 virtual environment that I'm using, and all that things, all additional modules that if you want to install, you can install and add additional plugin, you can add on to it. Everything is already configured. So I just come in here and then I say, okay, this is my directory level. I load this module, and for example, factorial is one of them. If I want to run it, and the output will show on the Python console. Right now on the Python console, I could just be like saying print, let's say 2 plus 2. It will just do those instructions. So 2 plus 2, not equal. 2 plus 2, it will just do those ones. And if you just do like import some modules, import OS module, there of OS, you could see all of the instruction the same way that you're inside the interpreter. At the same time, you have this terminal that you could get into the terminal, and then run Python commands. Like you could do dir here, you could say Python dash version, you could see all of the things, and you could get into Python, and then it will drop you to Python and exit out of it or quit out of it. You will do that one. And then Python console, Python terminals, all of that one is there. They're debugging tools. So let me open up the Python console, and then here, if you just click on run to compile it, if you just click on run, this environment tells you, okay, which one do you want to run? If you want to run the CLS, which was last time run, you could click on this. If you want to run any number of the modules that are loaded here, this is one module, this is one module, this. So in this case, I'm having a module called Factorial. Earlier, someone asked about the modules difference between modules and package. A package contains modules, but inside modules, you have Python code that you could call other modules. But then inside your modules, there are modules that are system level like math or sys or OS, but there are modules that you write, user-defined modules. Inside your user-defined modules, there are functions that are system-related functions, and then there are functions that you define, user-defined. In this case, I have a function called Factorial that does a recursive function, and this is the example for that one. So when I load this one, if I want to compile this one, Factorial, I could just say run, and then here on the list of the modules that I want to run, I just pick up the Factorial here, this one. Now it's going to run it, and then the output will show on the Python console there. So once it shows the output, then I can even resize this one if the windows is not big enough, so I can see the output. Notice that it runs in a Python virtual environment, and actually the full run command is this, and it says Factorial, and the working directory is the current working directory. So the working directory is important because it finds your modules on that directory. If you look at this working directory, there's lectures. And then since that one is there, this gets appended to the sys.path, and then sys.path knows that, oh, that's where I can find the module. If you're on a different directory and that you try to compile it, if this working directory is not loaded in your sys.path, it will just say not found, module not found. Don't get panic on that one. Use the Python, like PyCharm IDE, it will just help you, guide you to say where's your current loaded directory there. And then you could just specify that one on your sys.path and add it to it there. Under the setting, like I showed you earlier, a lot of those parameters could be set one time, or the IDE automatically detect it as soon as you start your coding on that directory structure. Say, oh, this is the executable directory. So you can see sys.path.extended. This one is, in addition to the system path that was earlier I was showing you for site packages and standard libraries, this gets added to the sys.path. So the word method extend is used, and these two are extended with the working directory and then other ones. And then later on, when it's called, it finds it. And then it goes to these lines, line by line. Even though it's an interpreter, it goes to line 1, and it, after line 1, Python, it does this definition, but so far it is, if I don't call it, it will not do anything. So since I just call it here on num line 4, I'm not doing anything, but I'm declaring it. Once I just say Factorial 4, then it's gonna go to jump into this function, and then it's gonna do these steps, and then give me the Factorial at the end. So Python, and then Factorial 4 is 24, Factorial 5 is 120, and 6 is 720, and so on. It will just look at the 50 as such a large number. So you could run the code here, similar to like a Fibonacci function. Fibonacci number or functions that are showing, let me run it first. So if I go run here, last time I ran Factorial, automatically defines that one. Now I want to run Fibonacci. I use that one and it's going to run. The Fibonacci is Italian mathematician that actually said that in order to calculate the next two numbers, the sum of every number is the previous two numbers. The sum of two numbers is going to make the third number there. So if I just look at these two numbers, 2 and 3 is 5. And 3 and 5 is 8. 5 and 8 is 13. So the sum of two previous numbers are giving you the current number when you're looking for Fibonacci numbers. And then in this case, if I just look for 100, 55 and 89 already is over 100, so it stops at 89. And the same thing with 610 and 987, it's larger than 1,000, therefore it stops at 987. But you can see that 0 and 1 is 1, 1 and 1 is 2, 2 and 3 is 5, and so on. So that's the Fibonacci number. And the way the formula works in the function Fibonacci, you declare a variable called n, in this case an argument or parameter called n. The parameter takes some value. In this case, the value is 20. If I want to get the first 20 numbers, I'm going to call the function Fibonacci with 20, and 20 is passed to this parameter n, then it's going to come into this assignment statement. And this assignment statement, instead of saying A is equal 0, B is equal 1, you could do multiple instructions at one time. For example, on you could do C is equal 2, 3, and then you could do that and then put C here, there. Or you say B is star, meaning that A is equal 0 and B takes the value of 1 and 3. And then if I have another argument 5, then B is 1, 3, 5 because of the asterisk. But I don't need that one, so I'm going to just go with my original configuration. I was just showing you how you could do these assignment statement. So 0 gets assigned to A and then 1 gets assigned to B in one line, rather than doing two lines like A is equal 0, B is equal 1. You don't need those two lines, you just do it in one line. So that's a short form of doing the same thing. And now A is less than n. If A is while condition checks for this condition. If this condition is true, it enters the loop. And then at some point that condition has to be false in order to terminate out of the loop. So with this condition that you're doing assignment statement here makes this statement at some point, this while statement, to be false. Whenever this is false, it's going to finish, which means these two numbers are bigger than 1,000, and these two numbers are bigger than 100, and these two numbers are bigger than 20. Therefore, it ends the loop. If you just don't have a false statement inside the while statement, this would be an infinite loop. You don't want to have an infinite loop in your while statement. So the while condition, while this condition is true, it enters into the loop, and then at some point it has to be false in order to exit out of the loop. So you don't have an infinite loop. In this case, A is less than n. Obviously, when A is equal 0 and n is equal 20, that's this. So it prints the A first, which is in the first case is 0, and then the next one is going to come back to this statement. At this statement, notice that we assign B to A to swap out the value. So B, whatever is B in this case is 1. B is 1, and then A plus B, 0 plus B, 0 plus 1 is going to be 1. So now B assigns the value of 1. The same thing, the next time comes in, the B was, let's say, 1, 1 plus the next number is 2, 1 plus 2 is 3, and so on. It just eventually reaches to a false statement, and then as it is done, it prints the numbers as right here. Every time it prints A and then prints the last one, and then it's done. So that's how the Fibonacci works. And there's also, see, that's this one. So this one is like a range command that is an example of this. You could test this one. Now notice in Python, as soon as I put something like range, so if I type in range and then use this, PyCharm automatically says that, oh, self-range, it starts with and it has other methods. So like here, if I put a start 0, then now I have another like increment by how many end with, start and end with 100, and then maybe a step over. Right here, a step is, and then I say, let's say 5. 5, so I will do this one and then print I. So if I just run this one and say run, it's still running the Fibonacci because that one was on the queue. So I'm going to run this other one called run here, and then I call T1. Okay, so it printed all the numbers from 0 through 100, but skipping each 5 of them. So the number is, let's run it one more time. The last number should be 95. Yeah, it's 95. So if I skip this one by 15 and then run it, it's going to be, the last number might be 85. And it's going to jump in faster this time, 90. 90, after 90, 15 is 105 already. So it is just going to jump in. Let's just do minus 5. Minus 5 does not make sense because I start with this, so I have to change this one to 100 and come down by 10, up to 10, and then let's say minus 10, minus 20. So I'm decrementing it by 20 up to 10 number, or I could go down to 0. So if I run this one, so the range function start is 100, ending 0, but because I'm negative, it makes sense. If I change this one to a plus, it's not going to make sense because this is semantically incorrect, saying that start with 100, go to 0. It doesn't know what to do with that one. So it did not compile anything because that statement, for a for statement, it did not have a range to do that computation. In order to do that one, I have to put 100 here and then 0 here. Start with and then increment it by 20, then it makes sense. Now it's going to print all the numbers up to 80 and then it stops. So that's like an example of range statement. And then you could also write something what, let me just undo that part. So right here, if I just comment this line, I could put also two statement like this. This is comment, or I could just do in one short form, I could do 3 double quote. So, and then put this line inside that. I could put that one inside this, and then that is commented.